Okay, thank you. Thank you for this introduction and thank you for having me here. I'm really excited to present about Quarkus and how Reactive has influenced the design of Quarkus. I'm also going to present Mutiny, which is a novel reactive programming library providing an homogeneous experience across the Quarkus universe for everything related to Reactive. But first, what is Quarkus? Well, Quarkus started around 10 years ago. And what we realized 10 years ago is that it was very hard to put Java application in the newly created containers in what was not yet named cloud. And the problem is that over the years, where we really realized that Java looks like a dinosaur on the cloud. If you compare it to Rust or Go or Node.js, it looks like way too bloated. And that's kind of unfair because the Java ecosystem is amazing. And we can't really say that Java is not cloud native, but we can make it better. And what we wanted to do with Quarkus is to make a stack that is truly cloud native, that will reduce the startup time, reduce the memory and CPU usage. It works for microservices, it works for serverless, it works for Kubernetes. It's been tailored for all these environments, but not only about that. So what's different between Quarkus and other frameworks? Well, if you use other frameworks, you build your applications, you develop it, then you do Maven clean package or SBT build or Gradle build. It creates a FATJAR, a WAR or something. And then when you start it, it's going to look at some configuration file on the files list system, do class path scanning, build a model of the configuration for each frameworks, and finally start some threads, start some pool and things like that. So it's kind of slow to actually start to do something. While with Quarkus, what we wanted to do is to move all these tasks at build time. So yes, it reduces the variability, but man, the benefits are huge. Typically, all the configuration, class path scanning, and model of the configuration are done at build time for each framework your application needs. And we augment the package with exactly what is required to configure the framework. So that means that when we start the application, everything is there. Just run this instruction, because when I say augmented, I mean generate the bytecode that is required to start your Hibernate, your HTTP server, and so on. Because of this, we reduce the startup time, of course, because we don't do this at runtime anymore, but also the memory, as we don't need to load classes to do the annotation scanning or bring a XML parser or something like that at runtime. So less class to load, less memory. But Quarkus is not only this. Quarkus is based on a great developer experience. You are going to see this in a few minutes. You just start your application, developed, it's hot reload for you, nothing to do, it's great. SUPERSONIC, SUBATOMIC, Java, I mentioned it in the previous slides. It's not only this, you may have heard about Quarkus' possibility to build native executable. It's actually a side effect from this build time pipeline we have, because during that build time, we can collect enough metadata to configure the GraalVM compiler or the Mandrel compiler very, very nicely and very precisely for your application. So you get a smooth native experience and very optimized for your application. Best breed of library and standards, you may not be aware of it, but you already have 10 years of experience with Quarkus, because we reuse libraries and standards from Jakarta IE, from MicroProfile, as well as from the open source community, such as Apache Camel, and you probably already use them. It's the same in Quarkus. Also, Quarkus is also trying to innovate in terms of development model, and we are going to see a bit of this later. And finally, and this is going to be the focus of this presentation, it unifies reactive and imperative. What I mean by this is that on the same stack, within the same applications, you can have reactive parts, reactive codes, and imperative codes, and they will be able to collaborate. And you can change over time. You can say, oh yeah, this imperative code is really too slow and I got too much pressure right now. I will redevelop it using reactive APIs and so on. Most of the APIs, if not all the APIs from Quarkus, are available in both reactive and imperative. So, but why does reactive matters? And why in Quarkus, when we started Quarkus, the exact project, so 2 to 3 years ago, why did reactive become one of the main pillars? Well, it's all about distributed systems, and every modern application today is a distributed system. If you're attending Reactive summits, you know that Reactive systems are challenging. They fail. They are really hard to get right. And it's not because we have the cloud or if we have Kubernetes that makes them easier to maintain and easier to build. Actually, it's quite the opposite, because yes, you can create ephemeral resources. In a few minutes, you can get a new database, a new VM, but that's only half of the story. The second half is your application. And this, you still need to handle yourself. And the tricky thing is that by creating ephemeral resources and by destroying them, it creates a dynamic availability issue that your application need to be aware of, making even harder to handle such kind of distributed systems. It's not only this. Over the past 5 years, a lot of usages across around our distributed systems have changed. Users are now a lot more demanding than before. They are always consuming your system, your services. IoT, never sleeping. You always have messages to handle or to send things to your IoT system or to your home automation system. Mobility, well, how many notifications did you get since I started this call, this talk? Probably 2, 3, maybe more. That's kind of things that a distributed system is handling. And if you're like me, I'm living in France, and so I'm still in lockdown. So remote work is everywhere. So your systems need to be handled to see this mobility, this new type of mobility. Finally, what we have seen over the last 5 years again is a lot of events. Events are there since the beginning of IT, but since a few years, they are back in the spotlight. Events will help you model the business process you want, the asynchronous of those business process. But also we are seeing a lot more events than before because of IoT, because of mobility, because of business intelligence. And this is a big deal because we need to be able to manipulate those events, to process them. And it's where Reactive is going to help. And Quarkus wanted Reactive for such kind of use case. First, event-driven. As I said, lots of events. So we need to be able to write code that say on event X do Y, event-driven logic. That will help you for IoT, for mobility, but also model your business process. That's also going to help satisfy your users, providing a better user experience. Second point, Reactive is going to leverage the non-blocking I/O layer from your operating systems, and this is going to reduce the resource consumptions. By using your resource efficiently, by this I mean CPU and memory, by reducing the number of threads and so on, we're going to see this on the next slide, you are one, going to handle more requests, more messaging, but two, increase your deployment density. If you have hard time to convince your executive layers that Reactive matters, this is the argument you need to use. Increasing the deployment density means deploying more on a set of resources, which means saving money, and that they listen to such kind of arguments. Quarkus already helped deployment density because of the fast startup time, low memory, but with Reactive, it's really the perfect compendium that makes this even better. So how does that work? Well, almost any Reactive frameworks are working the same way. So we have a non-blocking I/O layer at the bottom that do all the heavy lifting. Then you have a Reactive framework that transforms those code to make them more easy to consume by the application code. But here, to hold the benefits, to reduce the number of threads, it's going to use the I/O thread to call your applications. And you see this coming, right? How am I going to do this? Because that means that your code cannot block anymore. If you block one of the few I/O threads used by your applications, well, your concurrency is going to drop and the experience is going to be terrible. So you must not do this. So how does that work? How can we tame this asynchronous beast? By this, I mean, we cannot block. So we need to use asynchronous method, asynchronous call. I will say, I want to do this. And when you're done, continue with that. I need a way to express such kind of continuation. First way of doing this is callbacks. Of course, we all use callbacks. This is an example of Vertex HTTP server. And here we really see the event-driven nature of this. So on request, call this. onStart calls that. So we see those continuations that are expressed using callbacks. It's very elegant. It's very easy to understand, but it leads to callback HELL. And you don't want to handle such kind of code because even with Java 8 method reference, it's very hard to handle and very hard to understand. And again, you never write the code for yourself. You write the code for yourself in the future or one of your teammates. That's not a great gift for your teammate in 6 months. You can use features, you can use promise, you can use a virtual thread, but you lose a little bit this event-driven approach. Or you can use reactive extension or reactive programming, where you are going to use data streams as the main constructs, and you're observing them, and as soon as there is an item inside the data streams, you will get notified, and you can handle it. So there is plenty of operators that let you do fancy operation. We have an example here. The tricky thing with this is that you are quickly lost in a map and flatMap jungle. And over the past 5 years, when I was mostly focusing on Vertex, I had the opportunity to talk with plenty of customers and users of reactive programming libraries. And I generally had that question, well, flatMap for you, what does that mean? And even for seasoned developer with more than 5 years of experience, they generally get it wrong. 80% of the answer was not totally right. It's like, whoa, okay. So the tricky thing is that yes, it's hard, it's functional, it's not necessarily in the DNA of Java developers to understand those way of thinking. So we need to find a better way. That's why when we started Quarkus, we wanted to introduce a new reactive programming library that is named Mutiny. We want to avoid the nomad hell. The code on the left side of this slide is perfectly correct. It's using a web client to do some HTTP calls. Tricky thing, as I said, in 6 months, who is going to understand this? Why do I have a flattened flowable in the middle of this pipeline? This is very hard. And again, you don't write the code for yourself. So think about the person that is going to maintain this. Second thing, we want a navigable API. This is the type of code completion provided by IntelliJ when you use Eric Java. It's a lot of method. And if you look carefully, you see that it's still indexing. And I have seen developers looking at this, scrolling across the number of methods, trying to find the right signatures, without even trying to understand what the operators is doing. That doesn't really work. We wanted something a little bit different, a little bit easier to use. That led to Mutiny. Mutiny provides two types, multi and uni, and Mutiny is a contraction of the two types. Uni is for modeling asynchronous operations. It's a pipe that can emit one item or one failure. Multi is for stream of events. You can emit n items, failures, and completion events in the implement reactive streams. So far, nothing really new, right? It's the same thing like Project Reactor and Eric Java or others, a reactive programming library. The difference comes in how it structures this application. We have group of methods that are available using onX, onItem, onFailure, onCompletion that are dedicated to handle these events, onFailure, recover, onItem, transform, and so on. So thanks to this, the API is much more navigable and much more readable. Yes, it's more verbose, but verbosity is not a problem. We want something readable, we want something maintainable, something that in 6 months we can still understand. So far, this design is holding all the promises on all the expectations we were making into it. We even have really imperative developers say, oh, I finally got event-driven, I finally got reactive, and that for us is a great result. So enough abstraction, I need to show you some code because that's how you can see how it's used. And I'm going to develop this system here. I have a pre-populated Mongo database that contains superheroes and supervillains. As a French guy, I cannot pronounce villains correctly. So I will pronounce it the French way, and you will have to map inside your head to the correct pronunciation. Or I will just use the term bad guy. The sub service is going to retrieve a random hero or random villain and expose that as using an HTTP endpoint. We have a fight service that will call this endpoint and organize a fight between a hero and a villain. This outcome is going to be sent to a UI using SSC or REST, and also written into Kafka, which will be read by a stat service, which will just keep track of who is winning the most of the battles, heroes or villains. Okay, let's switch and see some code. So let's start with this. So first, I'm going to see if my system is working. I'm going to try to call this and see if I get a hello. Okay, I got a hello. Great. So this is this code here that is running. So it just, let me close this. That's Git. So it's just a handling GET request and returning hello. But we want to use Mutiny. So I'm going to do this here and say on greetings, I'm going to say bonjour. Up here like this. And now I go back here and I say greeting and no has, yeah, okay. And I should get bonjour right now. So what you see here is that I didn't have to recompile or anything. Everything is handled by the hot reload of Quarkus. So that's kind of nice, but you will see later it's actually quite awesome. So great, we got bonjour, but here it's kind of stupid because yeah, creating an asynchronous result for something I know is not something we should do. So we need something a little bit more asynchronous. So as I said, I have a pre-populated Mongo database, and I'm going to use Panache, which is a layer on top of our data access that make it easy to use and easy to consume. And Panache is coming with a reactive aspect, which is already Mutiny compliant. So here I'm going to write the code that is required to retrieve a random villain. So the first thing I will do is that I need to know the number of villains document I have in my collection. So this is villain.count. This is returning a uni of long. So when I have this result on item, I'm going to transform it to get a random number between 0 and this number. So I use a random that I've already created, and I will do int value. Okay, now I'm going to use a Panache tree to get a random document. So on item, once this index has been, this random index has been computed, I'm going to return a uni of villain, and this uni of villain is going to be retrieved by getting the page number index with all page of one element. This is a little bit tricky, but this is actually how the Panache API works. Generally, we don't do such kind of things, so that explains it. So I will do villain.find all, okay, and then I want the page index, and all my page got only one result, and I will get this result. And that's it. So what I'm doing here is just retrieving the number of documents, transform it when it's done into an index, into a random number, and with this index, getting the page that has this number and get the first result, and I return this. So obviously, if you are more a map and flatMap users, you say, well, but I prefer them. You can still use map and flatMap, but again, be careful that in 6 months, when someone else is going to handle your code, they need to understand what it means. So here it's relatively simple, but in the large pipeline we have seen before, it's more problematic. So let's now use this. So I'm going to return a hero when I call /hero, and that is going to be named hero. Okay, and I will just do hero.findRandom. I will do the same thing for villain. Yep, here villain find random, and I'm going to call this one villain, and I need to change this too. So let's try to see if this works. Can I get a hero? And yes, I got ancient one. Okay. Can I get a villain? And yes, I got, oh, I know that one. Harley Quinn. Okay, nice. So that works. Now let's switch to the second microservice. The second microservice is consuming this one. We can use a low-level HTTP client to do that, or use a REST client where we just annotate an interface with the same annotation we used on the endpoint to retrieve it. Like, okay, here I get, I call /hero, that the method is named getRandomHero, /villain, the method is named getRandomVillain, and that's going to call the right service. The service is this, the location is configured inside the application. So with this injected here, I can already start retrieving my subs.getRandomHero, okay, here, and subs.getRandomVillain. Perfect. Tricky thing. It's a distributed system. We need to be a little bit more careful here. So what I'm going to say is that if I don't get any item, oops, if no item, after, let's say, 1 second, then I will fail. Fail. Oops. Sorry. Fail. Okay. And on failure, I want to recover with a fallback. Here we go. I will do the same thing for my villain, except that here I need the other fallback. So now I got my 2 unis, but nothing happened yet. I need to combine them. So I'm going to do uni.combine all unis, so which are heroes and villain. Okay, I want both results when both will be emitted on a tuple, which will aggregate both items. And then when I got both, I will transform this and call the compute fight outcome method. So I got my tuple and I will do compute. And the first item on my tuple is my hero, and the second item is my villain. Okay, I return this and done. I just organize a fight between a hero and villain, and the hero and villain are retrieved from this other database. So let's see if it works. 8081/fight. That should make it. Come on. Yes, okay, so we got a fight between Tempest and Unicron, which is pretty strong, level 146, while Unicron won. So obviously, we don't necessarily want to use HTTP or curl for this. So I built a very addictive UI, which is this one here, and you can organize the fight. And the code is already on GitHub, so you can already play, and be careful, it's very addictive. After that, you don't have any private life anymore. So I told you, so try it, but at your own risk. Anyway, we need to do a little bit more here, and I want to actually trigger more fights. And what I'm going to do is that I'm going to trigger 1 fight per second. So yes, this. So I want to trigger a fight every second, but serve them using SSC, server sent event, so returning a multi, the second type from Mutiny. I will return a multi of fight, and here I will just do fight. So basically what this code is doing, it serves as a server sent event stream. Each event is encoded as application JSON. I create a stream that ticks every second, so create from ticks every second. And for every ticks, I will retrieve a fight. And this fight is going to call a hero and villain, organize it, and boom. So let's see if this is working. Here. Let's see. So yes, I got it. So every second we got a new fight. This is really SSC. We start seeing who is winning, but yeah, it's kind of hard to see and hard to see who is winning and so on. So we need to do something a little bit better here. What I didn't show you is that inside this compute fight outcome, there is this send to Kafka method. Here, it's using reactive messaging to send fights to a Kafka topic. Everything is configured, so you just say, okay, I want to emit on the fight channels, which will be mapped to the fight Kafka topics, and I just use this emitter to send the fights, which means that on the other side, we can consume it, and we can consume it using reactive messaging again from, I want the streams that come from the fight channel, so the fight topics, I will write to the stats channel, and what I do here, I get my fights, and on every item I accumulate and keep track of who is winning. This is served by the stat service as an SSC again. So now if I go back here and I do my stream here, okay, 0, but let's get some, yes, here. So we start seeing that we get the villains winning. Oh, we cannot keep it like this. Come on, villains cannot win, right? We need to have. It's kind of fair, but anyway, we are going to help a little bit the heroes. And for doing this, I will go back to my subs resources, And remember, in my fight service here, I did this. If I don't get an answer after 1 second, then I got this fallback, which is pretty bad in terms of level. It's a mini TX. It's a really bad heroes. So I'm going to delay voluntarily on purpose this to get to give more chance to the hero to win. So on item, delay it by, let's say, to be sure, by 1 second. So that means that it's going to retrieve the villain, but before passing it downstream, passing into the HTTP response, it will wait for 1 second, which will trigger the timeout we configured on the other side. And with this, we should start seeing, yeah, mini ticks already here. So you see, I don't have to reload or do anything. I write my code and boom, it's there. So now we got, oh yeah, we got the arrows that are starting to catch up. 43, oh, that sounds fair. Okay, so now it's much better. The arrows are definitely winning this battle. Pretty nice. So let's go back to the slides and finish this. Okay, so what we have seen in this presentation is just a little bit of the Quarkus universe and how it leverages reactive. At the bottom, we have of Quarkus, we have a reactive core, which is based on Vertex and Netty, and it's going to handle everything related to I/O. It's very efficient. It's going to use a low level of threads, low level of CPU. It's going to scale very, very well. On top of that, we have Quarkus extensions. We have seen a few, the REST client, how we handle HTTPs, reactive messaging. All these extensions, all these are frameworks which are most of them initialized at build time. So we do everything at build time. What can be done at build time, we do it at build time. So when we start, it's very, very fast. But as I said, Quarkus is about unifying reactive and imperative. So on top of that, we have a routing layer, which depending on your code will decide if it can stay on the reactive path, because until that we are on the reactive path, or if it needs to switch to an imperative path and use a worker thread. And you decide. And of course, if all your application is purely reactive, no worker thread is going to be used and you are going to be end-to-end reactive. We have seen a few reactive APIs that we have, but we have much more. In terms of data, we have Mongo, Redis, Postgre, MySQL, DB2, and a lot more. We can access it using Panache or something new that is coming, that is already merged, by the way. It's Hibernate Reactive. It's Hibernate with the power of an ORM, but based on reactive driver and using Mutiny directly. So it's pretty nice and actually quite fast. In terms of communication, we have an HTTP, of course. It's not the best things today. We have gRPC support with live reload and so on. Everything I say is live reload. Kafka, MQP, MQTT, Apache Camel. So we actually have a user that is using Quarkus built in a native executable, interacting with a whole COBOL application. That's amazing. Like, wow, it's like a shift of how many generations? 3 generations, something like that. It uses micro profile reactive messaging for almost everything related to messaging. In terms of web, we have a mail, templating, HTTP REST, GraphQL, and so on. We can also build a command line. We have support for command line and this. All this works equally well in JVM mode, where you get almost 20% of advantage in comparison to regular or traditional approach, or native. So all this works in native. Even if you go Kafka with Avro, it's going to work in native thanks to Quarkus. That's all I have for you today. You can already check out this demo at this URL here with all the instructions to run it. Again, the UI is pretty addictive, so be careful with this. You are going to generate a lot of files, I'm sure. You can know more directly in the Quarkus documentation. You can start immediately with code.quarkus.io and start developing immediately. You can ping the Quarkus team on Zlip, which is a kind of a Slack thing, a little bit different. Follow us on Twitter, and obviously you can contribute to Quarkus at this GitHub repository. If you like what you have seen today, you can go to this GitHub repository and give us a star. It's totally useless, but that makes us, the Quarkus team, quite happy. You know, developers, we are sometimes happy from nothing. Thank you very much. And now if there are any questions, I will be happy to take them.